Hey everybody! Today we're going to be looking at the wave texture and some cool things we can do with it. We'll take a look at all of the properties, inputs, and outputs, and then create a few different projects that use the wave texture. We'll create an infinite ripple in a water-like material. We'll use the texture to create a rolling field of mushrooms that scale with the wave texture. And we'll wrap up by creating an animated terrain with contour lines that use the wave texture in our shader editor. So let's get into it. First, let's bring a Geometry Nodes editor into our layout workspace. Let's get rid of the sidebar using the N key, and then we'll add a new Geometry Nodes modifier. We'll add a subdivide mesh to increase the amount of geometry we have to work with. And let's bump this up to 3 subdivisions. We'll go ahead and bring in a viewer node with Control-Shift-Click. Next, let's add our wave texture node. And we can go ahead and plug the color output into the value socket of the viewer so that we can see its value on our cube. We can see that we have one large stripe down the middle of our cube now. Let's go ahead and adjust the scale a little bit so we have more than one line to look at. What we are currently looking at is the bands type of wave. We can see that we also have an option for the rings type, and this definitely gives us a different pattern on our block. But let's go ahead and bring in a sphere and see how the rings look there. And this is a pretty neat pattern. We also have the option to change the direction of our wave texture. We are currently using the x-axis, but we can also change this to the y-axis or the z-axis. We can also change this to spherical in rings mode, which essentially creates rings outward from a single point. And this gives us something completely different. If we switch back to the cube, we can see that we also have a very different pattern here. Changing back to bands will reset this to the x-axis because bands do not have a spherical direction. Let's look at the bands option a little more. We can use the x-axis, the y-axis, or the z-axis, and we also now have access to a diagonal direction. And this also changes how our bands look and behave. We also have a few different wave profiles. Sine is the default profile, and we also have a sawtooth profile. We can see this change slightly on the cube. So let's bring in our sphere again to show the difference a bit better. Let's go back and look at sine, and then we can flip back to saw and see that it is a bit more jagged. We also have the triangle option, which is undocumented, but appears to give us some distinct angles in our bands. Let's switch back to our cube and take a look at the triangle profile there. And we'll go ahead and revert to the default sine. Next, let's talk about vector. By default, this maps to the generated vector you would get with the standard texture coordinate and mapping. But let's see what happens when we adjust this by bringing in a random value. Let's set this to vector, and that definitely changes the lookup quite a bit. If we switch back to our sphere, we can see that we get a very cool pattern, almost like stone or granite. Let's go ahead and remove our vector manipulation here. And we can remove this node as well. Let's look at scale again. This is the scale of our texture, and the larger the number here, the smaller our texture will appear. And we can see this on our cube as well. Let's take a look at the distortion input. This will, unsurprisingly, distort the bands or rings of the wave texture. The detail will adjust the amount of noise distortion detail. The detail scale will scale the distortion noise. The roughness will blend or sharpen the noise pattern. And the phase offset will move the bands or rings. And we'll come back to this later when we animate our little projects. If we remove some of our distortion, this is a bit easier to see. We can also plug in our sphere and see how this looks with the rounded geometry. And remember, we're just looking at values right now with the viewer, with black being 0 and white being 1. These can be applied to ridges with the set position, or really anything else you want to control with a value between 0 and 1. You can also use a map range or a multiply node to increase or decrease this effect. Now let's discuss the outputs. The factor and the color are essentially the same value, only the color output applies this value to all three axes. We can see that plugging either into the viewer has no effect on what we see. Switching to our cube also demonstrates the same values. Let's bring in a combine XYZ node. Whether we plug the color or the factor into the X, we get the same result. If we bring the factor in for all three axes, it's the same as plugging the color directly into the value. Similarly, we can plug the color into each axis and maintain the same result. This is cool, but what can we do with it practically? Let's move the viewer out of the way and bring in a set position node. Let's plug our color output directly into the offset socket. And we'll get rid of the viewer so we can see the actual geometry state. And we can see that our geometry has a lot of distortion now. You can see that the values were consistently offset by 1 in the positive direction, wherever we saw white previously. This is where our initial cube was, and all the points that moved did so up and to the right by an increment of 1 meter. If we change this to bring our factor in to just the X, we can see that the movement of vertices is directly to the right, or positive direction, by 1. While the other vertices with a value of 0 don't move at all and retain their original position. Similarly, we can attach the Y and Z axes. And again, plugging our color output directly into the offset gives us the same effect. Okay, I've about demonstrated that into the ground. Let's get to the fun stuff. I'm going to remove all of our current nodes except the output. Let's start by bringing in a grid. We'll set our size to 10 meters squared. And let's bump our vertices up to 200. We can also bring this into our output so we can view our grid. Let's go ahead and bring in a set position node. And then we'll add our wave texture. Let's also bring in a map range and we'll bring the factor of our wave texture into the value on our map range. And let's plug our map range into the offset. Next, we're going to set our wave texture to rings. We're going to change the direction to the z-axis, and then let's bring down the scale to around 1.4. We're also going to adjust our map range. Our 2 min will be 0.3 and the 2 max will be at 0. Wherever you set these will be the height of the ripple, so adjust them as you see fit. Next, let's come over to the shader editor and make some material for our ripple. Let's remove the principled BSDF first. Then let's add a mixed shader and hook it up. We'll bring in a glass BSDF and bring that into the first shader socket. Let's also add a translucent shader for the other shader socket. Next, we'll add a color ramp and we'll bring that color into the color of our glass shader. Let's create a light blue color on the right-hand side of our color ramp, and we'll bring that down to around midpoint here. Next, on the left-hand side, we'll add a purple shade. Let's go ahead and bring down the IOR on the glass shader to 1.3. Then we'll set the color of the translucent shader to a medium blue. Let's bring up our preview screen in the material properties to view our material. And we can adjust the factor of the mix until we're happy. Now let's head back to geometry nodes. And we're going to add a set material node. Let's name our material blue and then set the set material node to blue. Now let's turn on rendered mode in our viewport. And let's go ahead and bring in a mesh plane underneath our geometry. We'll bring this down on the z-axis and then scale it up with the S key. Let's create a quick material for our plane. We'll go for a blue-green and then bring up the metallic value. Let's head back to geometry nodes and select our mesh once again. Now it's time to animate. Let's make sure we are at frame 0 and then keyframe the phase offset at 0. Next, we'll move to our last frame. We can see that as we move into the negative, our rings radiate outward. But as we move toward the positive, the rings radiate inward. Since we are dealing with circles, using a whole number multiplied by pi will give us the exact result we need for continuous looping. So we'll set this to -8 times pi and keyframe. Blender will do the math for us. It's very good at interpreting expressions and recognizes the value of pi. We can play our animation and watch the rippling effect. Let's go ahead and bring in an area light. We'll move this up on the z-axis and scale it up a bit. Let's move over to the Object Data Property window and up the wattage to 600 or so. And that lets us see our animation a bit better. Let's place our camera at a good vantage point. Ctrl-Alt-0 will place the camera at your current view. Let's expand our window a bit and bring up the sidebar menu with the N key. We'll go to View and click Camera to View, and then adjust the framing until we're happy. Be sure to click this back off, or you can inadvertently reset your camera as you navigate around the scene. We'll close our sidebar and go ahead and render our animation. And there we have our simple animation. You can get some pretty cool effects with this logic, like by adding an instance on points and using the ripple to manipulate the position of the particle objects or instances. Let me know in the comments if you'd like a more detailed walkthrough of that setup. But let's move on to our next example, a moving growing field of mushrooms. Let's go ahead and delete our current wave texture and map range node. We'll remove the set material node as well. Let's update the vertices on our grid to 50 for each axis. Let's move our grid and set position over a bit to make more space. And we'll start by bringing in a noise texture. Let's also grab a Combine XYZ. We can bring the color from the noise texture into the Z-axis on the Combine node, and then bring the vector into the offset. Let's adjust the scale of our noise down to about 1.7. Let's go ahead and bring in a Set Shade Smooth node to make our ground texture less jagged. Now let's make some room at the end and bring in a Join Geometry node. We can add a Distribute Points on Faces node here and bring in the geometry from our Set Position node. Let's also add an Instance on Points and make some room over here. I didn't mean to hook this up here, so let's fix that. And we'll bring in our Distribute Points on Faces node. And we can go ahead and move this up and out of the way. Next, we're going to append our mushrooms and grass. I've used these collections in other videos, and I'll go ahead and link them here again. If you want them, you can download them from my GitHub repo. They're just something I threw together one afternoon and are 100% free for you to use however you see fit. Let's make the raw collections invisible here. Now we can bring in our grass collection. And we'll plug this directly into our instance socket. Let's check Reset Children, Separate Children, and then pick Instance over here. Let's bring up our density until we get a little better coverage. We'll also bring down the scale on the Z-axis to make our grass shorter but keep the thickness. And let's bump the density up a bit more. Since some of our ground is showing through, let's go ahead and create a simple brown material for it. We'll call this Earth and dial up the roughness a bit. Next, we can add a Set Material node and select our Earth material. In order to rotate some of our grass to give it a more natural feel, let's bring in a Random Value node. We'll set this to Vector and set the 2 max value for the X and Y axes to 0.1. Now we'll bring our Random Value node into the Rotation socket on the Instance on Points node. Let's bring in another Instance on Points node for our mushrooms. We'll come directly into that from our Set Position node. Let's bring in another Random Value node. This one we'll set to Boolean and bring it into our Selection socket. Let's bring in our mushroom collection and hook that to Instance. Again, we'll check the boxes for Separate Children, Reset Children, and Pick Instance. Let's hook our instance on points into our Join Geometry node. We can see that we should scale these down a bit, and we'll use the Instance on Points node for this. Now let's adjust our selection probability. Let's move these over and try bringing in a Distribute Points on Faces node. We'll change this to Poisson Disk and adjust our min distance a little. And we can bring our probability selection back up a bit. We'll also play around with the density max and see if we can get a look we like. We'll make a little more room for our viewport editor. We actually need to add another Set Position node here after the Shade Smooth node. Now we are going to bring in our wave texture. We'll bump the scale down just a touch here, and let's bring in another map range just beside that. We'll bring the factor into the value of the map range. Let's also add a Combine XYZ node, and we can bring the map range result into the Z-axis. And we'll use that for the offset socket of the Set Position node. And this is not what we want at all. We actually want to use this set position for our instances. So let's adjust that for our mushrooms and grass. Next, let's grab a position node. And let's also bring in a Separate XYZ node. Let's hook our position node in here. And we're going to add a map range node after that. And we'll bring in the Z value here. Next, let's bring in a math node. And we'll set that to multiply. We'll take our map range result and we'll bring that into scale. So as our mushrooms move up on the Z-axis, they will scale up. We're going to set our multiply to 0.23. Now let's move back to our 0 frame and keyframe the phase offset of our wave. I'm going to use the values that worked for me in testing, so I'll set the value at -2.2. Now let's move to the last frame, and we'll keyframe this at -14.05. Let's bring in the viewer node to make sure our bands are lining up. We'll bring the color output in as our value. That doesn't look right, but let's check by going to the start frame. We want these to line up so that our animation forms a continuous loop. Let's go back to the last frame and adjust our phase offset. You can use the Shift key while dragging the value to make fine-tune adjustments. That looks right now, so let's keyframe the new value. Now we can see that our wave texture affects the base mesh appropriately. I do want the angles here to be less steep, so let's adjust our map range to min and to max values. We will set the 2min to negative 0.02 and the 2max to 0.08. This will give us a gently rolling ground. Let's go ahead and remove our viewer node now. And we can see that our mushrooms are disappearing and reappearing, which is not really what we are going for here. After some off-screen troubleshooting, I determined what is making our mushrooms disappear. I should not have added the Distribute Points on Faces node, so let's fix that. Let's bring our second Set Position node directly into the Instance on Points node for the mushrooms. And that is definitely more of the look I wanted. Let's also adjust our map range 2 values a bit, bringing the 2min somewhere around 0.4 and the max at around 1.7, or wherever you think they look good. We can also change the seed on our random Boolean value until we find an aesthetically pleasing arrangement. Now let's go ahead and render. And we can see we have an effect almost like the ground is breathing. Now let's look at our last example, our landscape with contour lines. Let's first change the vertices on our grid. We'll go ahead and make those 80, and then we'll bring in a Set Position node. And let's add a noise texture. We'll update this to 4D so that we can animate it. And we'll add a map range. Then we'll bring in a Combine XYZ. Let's bring the factor from the noise texture into the value of the map range. And then we can bring the map range into the Z-axis of our Combine XYZ node. And we'll plug that into our Set Positions offset socket. Let's bring the scale down on our noise texture. Let's also go ahead and add a Set Shade Smooth node between our Set Position and Join Geometry. We'll bring our scale down quite a bit more until our landscape looks a little more gentle. On our map range, let's bring the 2min down a bit, and then adjust the 2max up a bit. This will give us higher peaks and lower valleys. We're also going to bring in a Transform Geometry node. And let's hook up our grid to this as well. We'll go ahead and bring that into our Join Geometry node. Let's adjust this on the Z-axis until it intersects our landscape geometry. And I'm going to bring this scale down a bit more. Let's go ahead and add the blue material we made earlier to our intersecting plane. And now we have some lake-like bodies in our landscape. Let's move our noise texture over, and we'll go ahead and bring in a mix node from the math subcategory. And then we'll duplicate this noise texture to bring into the other part of our mix. We're going to move our factor all the way to 0 on the mix node. We want to ensure that we are on frame 0 as well. Let's keyframe our W at 0 on the first noise texture, and we'll keyframe it at -2 on the other. We'll also keyframe the factor of our mix node at 0. Now let's move to the end of our timeline. Here, we'll keyframe our first noise texture at 2, our second one at 0, and we'll keyframe our mix at 1. If we play this, we can see our landscape shifting and moving. Now let's bring up another window so we can use a shader editor. Let's add a new slot and a new material. We'll bring in a color ramp. We'll bring up the left side about halfway, and we'll make this color a dark red. Let's make the right-hand side a little darker to a light gray. And then let's crank up the metallic. We'll also add a vector math node and we'll bring in a wave texture. Then we'll add a noise texture. We'll bring the color from each into the vector add node. And we'll bring the result of that into our factor for the color ramp. Let's switch the wave texture to rings. And we'll change the direction to spherical. Let's also bring up the distortion a little. We can open the Materials tab of the Properties window if we want to see our material. Let's go ahead and rename our material to Lines. And up in our Geometry Nodes editor, we'll make some room. And then we'll bring in another Set Material node. We can set this to our Lines material. And if we zoom in over here, we can see our contour lines. Let's adjust our camera a bit more. And we can close out our shader editor window. I'll zoom out on this setup and then we'll go ahead and render. And that's going to wrap up our discussion of the wave texture. I hope you found this video useful and informative. Please drop me a like if you've enjoyed this content. Thank you to all the people who have already subscribed, and if you haven't yet, consider this your personal invitation. It would really help support the channel. I hope you have a great day, and I wish you all a very happy blendering.